This question comes from me. It's a brand new chapter from the 10th anniversary edition of What If, which is now available online and in print. At the end of the laser pointer video, we built an array of lasers totaling 210 watts. Not only did this light up the moon, but it also violently ejected it from Earth's orbit. We figured that was enough power, but why stop there? After all, numbers can always get bigger, no one can stop you. So, what if we crank the power up even more? A 210-watt laser is powerful. When we turned ours on, the moon-facing side of Earth became significantly brighter than the sun. That's impressive, but the universe contains death rays that make our moon-obliterating beam look like a mere laser pointer. Enter the gamma-ray bursts. Gamma rays are just extremely high-energy photons. If you've seen a chart of the electromagnetic spectrum, gamma rays sit beyond X-rays, so energetic that they often don't even fit on the chart. These deadly bursts originate from high-energy cosmic events, such as nuclear explosions. But the most powerful of them come from collapsing stars. When massive stars die, their cores collapse under their own gravity, releasing enormous bursts of energy that rip the star apart from the inside. These catastrophic events often produce jets shooting out along the poles of the collapsing star, jets so powerful they can travel across much of the universe. If Earth happens to be in the line of one of these cosmic beams, we see it as a brief but intense flash of gamma rays. We didn't even know about gamma-ray bursts until we launched satellites to monitor for nuclear detonations on Earth. Instead, we found mysterious flashes coming from the depths of space. The peak power of these beams can reach an astonishing 10 watts, far beyond anything our laser array could produce. What would it take to match that power? To create a 10-watt death ray of our own, we'd have to give every single person on the moon-facing side of Earth a 210-watt laser. That's a laser 10 billion times more powerful than the one that ejected the moon. Of course, this is an implausible scenario, and it wouldn't work anyway. But before we get into why, let's imagine what such a beam could actually do. The ultimate laser beams spread out as they travel, but we'd have to focus ours carefully. The minimum angle of spread depends on the size of the beam source. A laser emitted by a 2-meter wide lens has a limit of about 0.1 arcseconds, or roughly 3/100,000ths of a degree. Interestingly, this formula mirrors the one used to calculate the resolution of telescopes like Hubble. In essence, a telescope is just a death ray running in reverse. If our original laser array had been focused into a Hubble-style beam, it could have fried planets across our galaxy. A 10-watt death ray would be far worse. If we tighten its focus to the diffraction limit, it could scorch planets up to 5-10 billion light-years away. But before you rush out to buy a 10-watt laser, there's a problem. The limits of power at extreme energy levels. Normal optics break down. A beam this powerful would start to exert its own gravitational pull. Photons carry energy, and energy creates gravitational fields. For an Earth-sized 10-watt laser, the photons at the outer edges would experience an inward acceleration of over 10 Gs. But the real showstopper is even weirder. Quantum mechanics predicts that if a beam gets too bright, space itself stops being transparent. Beyond a certain threshold, about 10 watts per square centimeter, electromagnetic fields become strong enough to create spontaneous pairs of electrons and positrons. These newly formed particles would absorb and scatter the laser's energy, leading to a cascading effect that ultimately halts the beam's progress. The final verdict: in the end, physics isn't math. You can always find a bigger number, but you can't always build a bigger laser. If you enjoyed this story, make sure to like this video, it really helps us out. Share it with friends who'd love to learn something new, and subscribe to the channel for more fascinating content like this. Don't forget to turn on notifications so you never miss an update. Thanks for watching, and I'll see you in the next one.